Hello, my name is Krishan Madan, and I am a student at Lehigh University for CSE2, and today I'll be answering questions 10 and 11 from the fall 2012 exam. The first question is question 10, and it's two multiple choice questions, and each question is worth 2 points, as you can see. The first question asks what a breakpoint is, and a breakpoint is a point in a program where the compiler does not read anything after that point. So the program executes up until that point, and you can debug the entire program up until that point. So it basically allows you to find errors in a selected area of the program instead of looking for errors throughout the entire program. And you can add a breakpoint by clicking on the margin on the left-hand side, and a red box will appear at the line where the breakpoint is set. And every line up until that breakpoint will be read by the debugger, and you can debug everything up until that point. So now that we know what a breakpoint is, and just to repeat, a breakpoint is something you can add to a program that basically stops the program from executing. It allows the program to execute up until that point, and at the breakpoint, the program stops executing, and then you can debug all the code up until that breakpoint. So that is what breakpoint is. We can just go through each of these options that you're given. And the first option is an error where where the error in your program lies, and that's not what a breakpoint is. The second option is a place where the debugger waits for input, and once again, that's not what a breakpoint is. The time at which a human cannot handle any more problems, no. So the answer would be D, none of the above. And the next question asks what an exclamation point means. An exclamation point in Java is a logical not symbol. So just as an example, on a sheet of paper over here, if I were to write 3 does not equal 2 as the condition for a piece of code to execute, so there'd be an if statement over here. There'd be brackets, and there'd be a piece of code underneath, those very poorly drawn brackets. But if I were to write that as a condition for a piece of code to execute, the code will execute because 3 does not equal 2. Or if I were to write, in general, actually, I should say, exclamation point true equals false. Oops, there we go. Exclamation point true equals false, because it is the not operator. So the options are given for the question are, let's go back. The exclamation point symbol denotes where the program becomes excited. No is a comment marker. No, a comment is a piece of a comment is something. A comment can be written using two slash marks or a slash mark and a star, and it can be anything. It does not affect the code at all. A comment is just often used by a programmer to explain to the person reading the code what the code means. It has no impact on the code itself. Is a bitwise OR operator. Now, an exclamation point, just like an OR operator or an AND operator, is a Boolean operator. It is used to it is used in conditions that can be either true or false, and are evaluated by the compiler to be either true or false. However, it is not the OR operator. The OR operator would be the shift key and this key underneath the delete key hit twice. So if you hit the shift key, you hit this key twice, that will give you the OR operator. But the exclamation point is not the OR operator. And then is a right associated Boolean operator, and it is in fact a Boolean operator, so that is what your answer would be. Alright, so now I'll be answering what question 11 means. And in question 11, you're given two mathematical expressions. Both of these expressions will be evaluated by the compiler. Even though they are complicated, the compiler will be able to read them and perform the math. However, it's unclear to a person who just looks at this code what mathematical expressions are evaluated first. So you have to add parentheses so that the order of operations denoted by the parentheses, matches the order of operations that the compiler will read the code. So for this problem, you obviously need to know how Java performs the order of operations. And we'll first focus on question A. And in question A, you have the operations that are performed are a casting operation. A casting operation is when a double is converted to an int, or an int is converted into a casting operation is whenever a primitive data type of one type is converted into a primitive data type of another type. However, if you converted an int to a double, it would be pointless because doubles have more latitude than ints do. Casting only makes sense if you're converting something that can accommodate a lot of numbers into a form of numbers that can accommodate only a certain type of number. And in this case, you have two doubles, x and y, that are being converted into ints. And doubles are numbers that have decimal points behind them, whereas ints are numbers that do not have decimal points behind them. So an int would be 0 or 1 or 3, whereas the double is any number with a decimal point behind it. So the double can also be a number without a decimal point, but if you have a number with a decimal point, it can only be put into a double. It can't be put into an int, because ints only accommodate numbers without decimal points. So in order to perform the casting operation, the 32.4 and the 357.2, both of those are read by the compiler to be 32 and 357. That's the first operation that Java reads, the casting operation. The second operation that Java reads is the multiplication operation, and Java reads the multiplication with left to right associativity. So the first multiplication operation is the 3 multiplied by the new integer y, which is 357, and then that product will be multiplied by 32.2. And the third operation that's read for question 11 is the addition operation, because multiplication and division have higher precedence than addition. So the third operation will be the product of 3 and 357 and 32.2, that product being added to 32.4. And then the final operation that's read is the comparison of that number with 73. Alright, so we converted the two doubles into ints, and then we did the first multiplication operation. And the reason we did the multiplication operation before the division operation is because multiplication has higher precedence than addition. So we performed the 3 multiplied by the 357 before the 32 plus the 3. Now we must perform the second multiplication operation, which is the 1071 times 32.2. And the 1071 is the product of 3 and 357. So for step 3, we have z equals 32 plus 34,000 times 486. Sorry about that 8. It's a very poor 8. 0.2 is less than 73. Alright, so we did all the multiplication operations now, and we can just proceed with the rest of the question. So now we have to do the addition, because that is the final mathematical operation. Well, no, I shouldn't say it's a final mathematical operation, because you have to also consider the equals and the less than. So z equals 32 plus 34,486.2, and that number is 34,508.2 is less than 73. So now less than, obviously this 34,508.2 is not less than 73. And Boolean z was in the original question so Boolean z was not declared in the original question. So Boolean z is false because 34,508.2 is not less than 73. Alright, so now I'll demonstrate the program on a compiler. So this is the original question. we have two booleans, boolean x, which is 32.4, and two doubles, double x, which is 32.4, and double y, which is 257.2, and we have a boolean z, which is equal to the double x cast into an int, plus 3 times the double y, which is cast into an int, times 32.2 is less than 73. And then I printed out z to find the value of z. So if we compile this program, and I'll show you over here, so this would be Javac, sorry, let me just do this for a second. Alright, so it's the program name .java. Once you compile it, we get no errors, and then we do Java does not equal, and we get false. So so the value of the boolean is false. Now let's add parentheses to reflect the order of operations. So back in the original program, the first operation that is performed is the multiplication operation. So you add parentheses to reflect that. So you're going to add, sorry, let me put the camera down so I can add the parentheses. So the first set of parentheses reflects the fact that the 3 is multiplied to the 32.2. And the second set of parentheses will reflect the, the first set of parentheses, that was a mistake, will reflect the fact that the 3 is being multiplied to y. So let me just add that. I made a mistake. Now the second set of parentheses will reflect the second multiplication operation, which is the product of the 3 and the new integer y being multiplied to the 32.2. So let me just do that. And there is your second set of parentheses. Now the parentheses need to reflect the addition operation. So you're going to add parentheses around this whole entire mathematical operation. And there we go. So now let's test if this gives you a false also, which is what the original question gave you. So you first need to save the program, then you need to compile it. And now you need to run it. So there we go. This is me running the program. And we get false. So the parentheses did reflect the order of operations. And here is the final. This is what you would write onto your test. Alright, so now my next question is question B from the fall 2012 exam for question 11. So question 11, part B from the fall 2012 exam. And in this question you have 4 strings. 3 of the strings are established in the beginning. The 4th string is a concatenation of the first 3 strings and a mathematical operation that's performed. Although as string T actually in string T there is you don't even use strings Y and Z, so you can just ignore those. They're kind of a diversion. String X is the only thing that's used in string T. So I wrote this exact question in the compiler, and I wrote parentheses that reflect the operations I performed. But let me just X those parentheses out and get back to the original problem. So let me just get rid of that. And so this is what we originally had. And in the original problem, the first thing that the compiler reads is the casting. And the casting is when a primitive data type of one type is converted to a primitive data type of another. So the 25.5 and the 39.3, those are both, they can only both be doubles. They cannot be ints because ints do not carry numbers. You cannot store a number with a decimal point after it into an int. So they have to both be doubles. So if you cast a double into an int, it slashes off all the numbers beyond the decimal point. So the 25.5 becomes 25, and the 39.3 becomes 39. And that's because when a double is cast into an int, the numbers beyond the decimal point are cancelled. Now you must add parentheses to reflect the fact. Well, these don't add parentheses. These are already in the question. The parentheses are there that reflect the fact that the program first reads the 25.5 is multiplied by the 39.3. So this is the first multiplication operation that's read, the 25 times the 39, because there are parentheses around this operation. This is unusual because normally in a Java program, it would first read the 3 multiplied with 25. And the reason why I would first read the 3 multiplied by the 25 is because, and this is assuming there's no parentheses, is because Java has left-to-right associativity. However, this is assuming there are no parentheses. The parentheses change the order of operations from what it would be without parentheses. And because there are parentheses, the multiplication operation that's read is the second multiplication operation. So now that this is the first operation that's read, you need to add parentheses to reflect the second operation that's read. And the second operation that's read is the multiplication of 3 with this product. So you're going to add parentheses to reflect that multiplication operation. So I just added a set of parentheses to this problem that reflects the fact that the second operation that's read is the 3 multiplied by this product. Now the third operation that's read is this division operation. Multiplication and division are interchangeable because, I mean, whatever is left, whatever is first is read, so they have equal precedence. However, in this particular problem, even though the multiplication and division in general have equal precedence, in this particular problem, the multiplication has prior precedence because the multiplication is before the division. So once again, the multiplication and division have equal precedence. They're both read before addition, but the multiplication in this problem is read first because the multiplication is before the division. So you need to reflect the fact that the division is read. So you're going to add parentheses over here. And so this is what your final answer should look like. So this is what your final answer for question 11 should look like. This is, on the top is the code for question 11A, and on the bottom is what question 11B should look like after the parentheses are added. This is Krishan Madan, and I have answered questions 10 and 11 from the CSE exam for fall 2012.